Welcome to Metal Casting Lecture Series by Professor Joyjeet Ghose. This is the third lecture of a series of lectures. This lecture will be on sand casting processes pattern. He will be discussing about what is sand casting pattern, pattern materials, selection of pattern materials, properties required of a good pattern material and types of pattern and their application in sand casting. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this third lecture on series of lecture on casting. This lecture will be dedicated to sand casting pattern and pattern making. So all the pattern making discussions or pattern discussions that we'll be doing here will be related to sand casting. So what is the sand casting pattern? Sand casting pattern is a principal tool that is used in sand casting to create a shaped cavity in a moist molding sand. Now this pattern is of a shape which is similar to that of the final casting. The reason why I am calling it a similar shape is because it is an approximate shape, because it has allowances attached to it apart from the core prints. The core prints and the allowances plus the shape will make the shape of the pattern, which will be, you will understand in a subsequent slides what I mean by an approximate shape of the final casting. It is not an exact replica of the final casting, rather an approximate replica of the final casting. So using this approximate replica, which we are calling it as a pattern, we make a shaped cavity in a moist molding sand, which is held in a flux. The complexity of the shape that we can cast is limited to the complexity of the mold that we can create. And the complexity of the mold that we can create will depend on the complexity of the pattern that we can create, and we can insert it in the mold and we can take it out without destroying the mold. So that is our limited. If the shape is complex, and we can also make a pattern which is a complex shape, but if we cannot take it out because the shape being such, then we cannot cast it. Okay, but there are techniques available where complex shape or pattern we can take it out. That you will understand as our discussion progresses. That you will understand. But you should understand the limitation of the complexity will be limited to the shape that we can take it out from the pattern. Pattern not only has to be inserted in the mold sand to moist sand to give a shape, but it has to be taken out. That's also important. Now, what is this material with which the pattern is made? The pattern can be made of any material which you can give a shape easily, because ultimately you have to make a complex shape, and then therefore the pattern material should be so chosen that we can give it shape easily. You can select any material. Some of the commonly used materials are wood, primarily used. Metals also used widely. Metals like iron, cast iron, metal like steel, metal like aluminium, brass, etc. are used as pattern materials. Also, you can go for rubber, gypsum, plastics. All this can be used as wax. It also can be used as a pattern material. I mean, wax is normally not used in sand casting. It is used in investment casting. So there are various types of pattern making materials. So let us see. Pattern is a model of the casting to be cast, so constructed that it may be used to form an impression called the mold cavity in the molding sand. The mold cavity should be capable of producing the required casting. When this cavity is filled with metal, the metal is allowed to solidify. It forms the required casting. The pattern is therefore an approximate duplicate of the required casting. And it has core print and the required allowances in order to produce the required shape. Suppose in this example, this is the dumbbell shape, we having an internal hole having an internal hole. Now this hole has to be required, for producing this hole we required to use core. Now for inserting the core in the mold, we require core print. So therefore the pattern should have core print attached to it. So the pattern should look like this. These are the core prints. Also, there are various allowances added to this casting, and if we match it up, you can see it is slightly larger, and therefore it is called allowances. Plus, you will see that these straight edges are difficult to produce in casting, so we'll be using tapered edges, which is not shown here. The pattern will be slightly tapered. These are also allowances. So therefore, in my previous slide, I had referred that it is a approximate duplicate. Probably now you will understand why I called it an approximate duplicate, because the allowances and the core prints are attached to the pattern apart from the shape. So you can say, in a sense, the casting shape plus the core print plus the allowances makes the pattern. This is another example which I have taken from NPTEL lectures. This is the job with having an internal hole, similar holes. So you can see here, these are core prints. So in this core prints, the core is fitted, and you can see this straight edge is tapered, and it is slightly bigger than the final casting. So this is the use of pattern. So pattern material already I have discussed. Okay, on what basis you will be selecting the pattern material? Now, depending on the quantity that has to be cast. If you know that using that pattern we have to create mold, and huge number of castings has to be done, so huge number of molds has to be prepared. Therefore, you can invest heavily on the pattern, and because the pattern has to last for that number of casting. So in such cases, you can go for expensive patterns like metal patterns. Various types of metal patterns are there. Next, quality of the casting you want. Now, some pattern materials produces better mold cavity, and better mold cavity produces better casting. So metal pattern produces better mold, and therefore the cast quality of the casting is also better, because surface finish obtained will be better. Whereas wooden pattern will not give that much good surface quality compared to that of a metal pattern. Intricacy of casting. Now, if you are very complex the casting, then machining the metal pattern may be difficult, whereas a wooden pattern can be easily machined and given a shape. Sometimes size of the casting is very large. Now, when size of the casting is large, if you make a metal pattern, then the size of the pattern will be very large, and it will be heavy for the foundryman to carry and operate using that pattern. So in such cases, lightweights like wooden pattern will be much more advantageous. These are the factors. Again, you expect that the design will change frequently, and you don't want to invest heavily. In such cases, a wooden pattern is ideal. So these are the factors which you have to take into account while selecting the pattern material. Now, every pattern material has a certain good qualities. What should be the good qualities of pattern material? It should be easily shaped, worked, and joined. It should be lighter in weight. These are desirable, not necessarily essential. It should be strong, hard, and durable, dimensionally stable in all situations, easily available at low cost, repairable and can be reused, able to take good surface finish, resistance to wear and abrasion, resistance to corrosion and chemical reactions. Okay, it is obvious that all material will not have all these properties. Some material will have some good properties listed out here. Some will not have it. So depending on your requirement, but these are desirable properties. Okay, this I have taken from P. N. Rao book. This is the comparative characteristics of all metallic patterns. So these are the advantages and disadvantages of different metallic pattern like aluminum alloys, grey cast iron, steel, brass, and bronze. So some you can see are heavy, some has good machinability, some has low density that is lighter, some takes good surface finish, some are corrosion prone. So these are certain advantages of metallic patterns. Also, whether to select metallic pattern or wooden pattern will depend on the size and the number of casting. So this table I have taken from P. N. Rao book, which lists out or gives a direction to select the pattern material based on the size under 600 mm or the number of casting, which material will be ideal. Mind you, these are a directive only, and not necessarily you have to follow this. Okay, so with this we move on to different types of pattern. Patterns are of various types. The most common type is single piece pattern or solid pattern. Now, single piece pattern or solid pattern is basically, as the name suggests, it consists of a single piece. And the reason we are making it a single piece is that it is easy to take it out. Certain shapes cannot be taken out using a single piece pattern. So certain shapes like this, we can easily take it out, and therefore we use a single piece pattern, and it does not create any withdrawal problems. Whereas certain shapes like this shape, the dumbbell shape, now if you want to take it out, so this shape will be destroyed. The mold will not be of this shape. If you take it out from this side, see, if you take out, if this is single shape, and if you take out, so it will produce a somewhat a cylindrical shape, not the dumbbell shape. Okay, so therefore we have to prepare the casting pattern in two parts. This is the cope half of the pattern, this is the drag half of the pattern, and the dowel pin. This is the dowel pin. The dowel pin ensures that the upper half and the lower half matches properly. There should not be any mismatch. If there is a mismatch, the casting will be produced in a mismatch manner. So therefore, it is essential that it should be aligned perfectly. Therefore, the dowel pins. And this will be used for making an impression in the cope. This will be used for making an impression in the drag. And you take it out from the drag, you take it out from the cope, and then we fit it, the drag and the cope up of the flux to produce the mold. So this is a stamped pulley, 3-step pulley. This is a core print for making the central hole. So this shape we can easily take out from this side without creating any problem in the mold. So therefore it is a single piece pattern. This shape we cannot take it out in a single shape. So therefore it is made of two shapes in the cutting line, one for the cope, one for the drag. So this is the drag half, this is the cope half of the pattern, and you can see these are the dowel pins. So this is a single piece pattern. You can see this is the drag half of the pattern and the flask. So drag half, the first it is placed, molding board is placed. On the molding board the pattern is placed. Then it is rammed, the flask is placed, and it is rammed with the molding sand. And then it is inverted, this half on top of this side, and on top of it the cope is placed. And again the gating systems, the screw rod and the riser rod are placed in position and filled with molding sand and packed. Then it is opened like this, and the pattern is then taken out. We have the mold cavity. Then the cope is assembled and vents are made, and we can pour it like this to get the final casting. This is a single piece. Now why is single piece? Because we can take it out easily without disturbing the mold. Okay, now match plate pattern. In match plate pattern, we have a plate. On top side we have the cope half of the pattern. On the lower side we have the drag half of the pattern. And in this we have the sprue and the riser also attached to the pattern. So this is normally used for large size casting in machinized or automated molding foundries. This type of castings are used, the patterns are used. So this is a match plate pattern. You can see this is the top half, this is the cope. You can see this is the sprue basin, this is the sprue rod, these are the runners, these are the casting. And this is the bottom side, rack side. You can see the lower half of the casting. Then we have cope and drag pattern. Cope and drag pattern are made with two plates, one plate containing the cope and one plate other plate containing the drag. Both are aligned properly to be used in cope half of the flask and drag half of the flask. These are also used in automated foundries. or automated molding purposes. These are mainly used for larger production quantities. Of course, these are expensive patterns. So you can see this is the cope half, this is the drag half of the pattern. You can see the runners are attached to it. Then we have gated pattern. Now gated pattern, see here, number of castings are made using a gated pattern because there are a number of gates. So these are runners, these are runners, these are gates. Okay, so the number of gates are made and number of casting are done. So this is screw rod and the pouring basin attached to it. So we don't have to use screw rod separately. It is a part of the pattern. And loose piece pattern. Sometimes the shape of the pattern is such that it is difficult to take it out without breaking the mold. In such cases, we use loose piece pattern. So it is a double fitting, a dovetail fitting is there. So you take it out, this part, and then this part is moved here and then taken out. Moved here and then taken out. So this is loose piece pattern. I'll show you. This is also gated pattern. This is a loose piece pattern. You can see here. So here, this is removed first. Okay. Then this is with the spike bar. This is taken out slowly like this. So this is a loose piece. Sweep pattern. Sometimes if the shape is asymmetrical and large, like a wheel, solid wheel, the pattern will be very heavy and difficult to handle, and also it will be costly. To reduce the cost, we make a section of it and fit it in an axis and rotate it in the sand to generate the mold. So such type of patterns are called sweep pattern. You can see this board is a section of the final casting, which is a bowl shaped casting. It's a bowl like this. So it is fitted in the bottom side here. The axis, this is the axis of it, and it is rotated on the sand to create the mold. Whatever loose sand is there, it will be removed later on from the mold, and you create the mold. So you can see this is the sweep pattern which we have in our foundry. So you rotate it like this. So you can rotate it and you can create this kind of mold, which is axisymmetric, which is symmetric about the axis. Now mind you, if you want to create separate ribs, number of spokes in a wheel, by this pattern is not possible. In that case, we have to use segmental pattern. So segmental pattern as a segment of the final casting. It may be a 1/6 of a segment. Let's say it's 1/6 of a segment. That means it has 6 spokes like this. So you make the mold by 6 times pressing it in the sand, slowly moving in this direction. This is called segmental pattern. Then we have skeleton pattern. As the name suggests, sometimes if the size of the casting is large, if you make a pattern, even if it is a wooden pattern, it becomes very heavy and it becomes very difficult to handle. So what you do is that you make a skeleton of wood using wooden frames, and you pack it with loam sand. What is the loam sand? Loam sand is sand which is mixed with clay. Clay and sands are mixed, and you pack it up with the loam sand, and there is a strike bar. The excess sand is removed by the strike bar to give it its final shape, just like a skeleton. And you can say the loam sand forms the muscle. This is a strike bar. Fill it up with loam sand, then with the strike bar you remove the excess sand and give it a shape. So this is the strike bar. You fill it with loam sand and then give it a shape. Okay, then follow board pattern. Sometimes the shape of the casting is such that if you make a pattern of that shape and place it in a board which is plain and flat, then it will be dislodged or it may even break under the pressure of the ramming. So what do? You follow the profile of the pattern by the board. You make a board which follows the profile of the pattern. Such a pattern is called follow board pattern. So this is a follow board pattern. This is a follow board pattern. And there are other types of pattern which I am not discussing, not that important. Cell pattern, built up pattern, and legged up pattern. This is a three-piece mold. The middle part is called chick, drag. This is scope and drag. This is called chick. So pattern making allowances we'll be discussing in the next lecture. Thank you for patiently hearing. In case of any doubts, feel free to contact me.